Okay. So continuing our graphing, today we're graphing absolute value equations. So in case you've never seen an absolute value equation graph before, our parent function is y equals the absolute value of x. Okay. So if we make a table for this, say x, y, pick our default numbers, -2 to +2. Okay. So if we have -2, the absolute value of -2 is +2, absolute value of -1 is 1, 0, absolute value of 1, since it's positive, it just stays the same, absolute value of 2 is 2. Okay, so if we plot these points, and you will see it makes a nice V shape. I can do that better. Maybe. Let's go slow. Yes, okay. So it extends out forever, just like that, okay? So that's an absolute value function, because we know no matter what we put in for x, y can't come out negative, so it stops right here, then it goes in the opposite direction. So anytime you see a graph that looks like a V, you can be like, that's an absolute value. Oh, our function. Let me put this over here. And then we're going to look at every other kind of absolute value. Not every other, just more basic. We'll get to the more complicated stuff later. So what if I just want to know, what would the graph of y equals, let's say, x, or absolute value of x minus 2. Okay? So I'll make myself a little bit bigger table here. So I'm going to put x, absolute value x minus 2, so I can actually see the work, and then y on the right. Okay, so when we pick our points here, this is a big deal, because we see how there's a vertex, just like when you did parabolas. There's this minimum or maximum point, which for today, it's always going to be the minimum. And that's where the value inside the absolute value bars is 0. So that's a point we're looking for. So if we have x minus 2, what would x need to be to give us 0? And hopefully you say positive 2. I'd say good. So I'm not gonna start with -2. I'm gonna put it in the middle. So I'm gonna pick a couple numbers smaller than that, a couple numbers bigger than that. But I know 2 is a key point. So I'm also gonna put 1 and 0 and 3 and 4. Okay? So we do the work. So the absolute value of 0 minus 2. So that'd be -2. The absolute value of -2 is +2. For 1, so it'd be 1 minus 2. So that's -1. The absolute value of -1 is +1. 2 minus 2 we said was 0. And then the rest is all positive, so it's just like you're subtracting. 3 minus 2 is 1. 4 minus 2 is 2. Okay? So we can see it here. That makes our V shape. It goes down, then it comes back up. So we plot this out. So we have point of 0, 2, 1, 1, 2, 0, 3, 1, and 4, 2. Okay? It's not perfect. It'll work. You get the idea. Okay. So we see it's the same graph, but here's the point. This is what we're going to need today. We say it shifted over to the right. So we have -2, it shifted to the right. And hopefully that sounds familiar if you remember transforming quadratic equations. It's the same similar idea here, and we'll get more into the rules in a little bit. Okay, so let's pause it if you need the table. So I'm going to get rid of the table. Okay, what if we went the opposite way? What if I said y equals x plus 2? Hopefully, using your power of context clues, you'll be able to guess what's going to happen here. If not, we're going to make a table, same as before. So x, absolute value x plus 2, and then y. So again, in the middle, we want to pick a point that'll make this absolute value equal 0. So what plus 2 is 0? It's -2. So I want to put -2 in the middle of my table. And then I want a couple numbers bigger than that, a couple numbers smaller than that. bigger, smaller. Okay, so -1 and 0. That's wrong. Sorry, I'm going the wrong way. That would work too, but in my order is weird. -3, -4, -1, 0. Okay. So the absolute value of -4 plus 2. So -4 plus 2 is -2. Absolute value of that is 2. Let's see. -3 plus 2 is -1. So absolute value is +1. -2 plus 2 we said was 0. Hopefully they're like, Ellis, this looks like the same table, only slightly different. And I'd say that's correct. You're seeing the pattern. If you don't see the pattern yet, that's okay. So 0 plus 2 is 2. How's it going? The absolute value of that is just 2. All right, so here's our points. So we start at -4, +2. Let's just go back up. So -4, -3, 1, -2, 0, just like that. Okay. So we see, same as before, only instead of shifted to the right, when we have x plus 2, it shifts to the left. Okay. So we're halfway there. That's how we move it left and right. Now hopefully you're saying, well, what if I want to move it up and or down? And I say, okay, let's do that. So if we come back to our parent function, and what if we say, what if we leave that alone? What if we say absolute value of x, and then I just put +2 at the end? So if I make my table, so x, absolute value of x +2, and then y. So for this one, if I want to know where the vertex is, it's still what makes the absolute value 0. So if it's just a single number, it's going to be 0. So I can use the same set of x values as I did in my parent function. Well, what's going to change now? So this is going to be -2 plus 2. So that's going to end up being 2 plus 2, which is 4. -1, the absolute value of -1 plus 2 is, it's going to be 3. Absolute value of 0 is 0, plus 2 is 2. And then going the other way, absolute value of 1 is 1, plus 2 is 3, and hopefully you see the pattern. Okay, so we have 4, 3, 2, 3, 4. Makes a nice V shape. So we plot it out. -2 up 4 is up here. Just like that. So there you go. So if we want to shift the graph up, you just add a number at the end. And then I'm not going to work it out because this one's a lot more straightforward. If I want to shift it down, instead of doing plus a number, just do minus. So if we look at the actual examples, we can say, we can come up with some rules here. And then we'll talk about the inequalities part. I realize we skipped entirely over the inequality section. So if we say y, we just say equals for now. Y equals absolute value of x plus, and they use h and k for this. And that's the same as like a or b. They're just generic variable names. So if h is positive, we shift to the left. If we have negative value for h, we shift to the right. If we have a positive k value, we shift up. And if we have a negative k value, we shift down. So really this comes out to like a really simple idea of we just look at these two numbers. And again, these graphs will get more complicated because we can add way more than what's here. But for now, we just have h and k, and that's going to move it left, right, up, and down. So if I see y greater than absolute value of x minus 2 minus 2. So h would be -2. And k is also -2. So if h is negative, it shifts to the right. So my vertex is going to move 2 to the right. And k is negative, so it's going to shift 2 units down. So this is going to end up being my vertex point. And then it's going to keep that same V shape. So I can plot my points in a basic V. Okay? Now at this point, now we can actually look at the inequality rules, which is the same as yesterday. So less than or greater than, instead of making a solid line, you're going to make a dashed line. Okay, and these ones, we can go all the way to the end of the table. If it's greater than, same as before, you're going to shade above the line. If it's less than, shade below the line. So for this one, we would just shade everything above. And there you go. That's your graph. Not too bad. You don't have to do a lot of math at this point. Later on you will, but for now, it's nice and simple. So our second example, y less than or equal to x plus 2 plus 2. So h equals 2, k equals 2. So if h is positive, we shift it 2 to the left, 1, 2. K is positive, so it shifts 2 up. So -2, 2 becomes our vertex. Again, we keep our basic V shape. This time it's less than or equal to, so it's going to be a solid line. This continues forever. And it's less than that, so I'm going to shade everything below the line. And there you go. So the explanation takes a while, but once you get it, you go, oh, this is easy, and you go through it, no big deal. All right. Again, if you don't get it, feel free to ask questions.